Okay, so in this penultimate part of the lecture, I want to demonstrate practical estimation of the linear mixed model in R. And to do that, I'm going to return to the Oxford data on boys' heights in centimetres and standardised age. And standardised age is dimensionless. It's simply allowing for an easier comparison of individual growth curves on a standardised basis. So I've included the R code for linear mixed model on the slide. Estimation is using the MLER function from the MLE4 package. You can see the package listed here. I've loaded that library. So we load the library, we read in the data, which are available, of course, for you to play with in your own time. And we estimate the model with LMER. Now note the syntax carefully. We have height tilde 1 plus age. That's specifying the fixed effects. The one requests an intercept. In this case, you have to specify that. And the expression in brackets, 1 plus age given subject, specifies the random effects. So we're asking for a random intercept and a random slope coefficient on age. And those we're asking for them to vary by subject. So the bracket is telling the software what the random grouping is. We set REML equals true for the reasons discussed in the previous section. We're going to estimate by REML, not maximum likelihood. And we then put the command here to summarize the results. And here's the output. We get REML criterion at convergence and diagnostics on the scaled residuals. Then, and this is the distinctive feature of mixed model output, we get two distinct blocks of parameters, the random effects parameters and the fixed effects parameters. First, the random effects block. The variances and standard deviations of the intercept and slope random effects by subject, we get their correlation and the residual variance. Below that, the number of observations, 234, and the number of groups or subjects, 26. Second, we get the fixed effect block, the estimates, the standard errors, and the t-values, just as we would from a normal linear model, so the usual regression style output. So let's interpret these estimates. We'll start with the fixed effects. The fixed effects estimates give the population means, so an intercept of 149 centimetres and a slope of 6.53. So standardized age has a significant positive relationship with height, just as we would expect, and that's what those numbers are telling us. The variance components, the REML estimates are 65.30 for the intercept random variance, 2.83 for the slope random effect variance, and 0.44 for the residual variance. And the estimated correlation between the random effects is 0.64. So from these, we can form the REML estimate of the psi matrix as shown in the slide. This is it given here, with the covariance computed as the correlation times the product of the standard deviation given 8.69 on the two cells here. And this is the structure that allows for error correlation and heteroscedasticity. Finally, the blocks of the random effects can be calculated. The command ranf recovers the best linear unbiased predictions of the intercept and slope effects for each of the 27 subjects. And the figure on this next slide plots the resulting subject-specific fitted values against standardized age. And this is the plot here. The LLM fitted values against standardized age, one panel per subject for the 26 subjects. Note the subject-specific interpretation of the LLM is at work here. Conditional on the values of the random effect, we have quantified a different intercept and a different slope for each subject that we have, for each one of the 26 boys. And remember how this was achieved. This was achieved with just 6 estimated parameters to get these predicted random effects. Those parameters are the 2 fixed effects and the 2 random effect variances, the residual variance, and the correlation between the random effects. So I hope that this example demonstrates the power of the linear mixed model. It accommodates non-spherical structures, and it strikes a balance between a population average model and a subject-specific model in a single, very parsimonious step.